Alright, so let's work Pathways 2.64. This asks us, are molecules present in a sample of BaF2, which is known as barium fluoride? Now, whenever we're dealing with an ionic compound, such as barium fluoride, this is when metal and nonmetal comes together. We get a complete transfer of electrons to form charged particles, cations, the positive charge, anions, the negative charge. When we have that situation, the ions come together to form the ionic compounds. Typically speaking, molecules are not really existing, okay, in the way that we think about them in terms of covalent bonding, where we have an individual entity of atoms bonded together. Instead, ionic compounds, such as barium fluoride, tend to organize themselves in relatively complicated three-dimensional solid structures that are crystalline in nature. These reflect a very, very high degree of organization of the ions, and we can kind of see that in the picture here, which represents barium fluoride. The model for this is a lot like balls or spheres of different size or diameter that are packing together to form a three-dimensional lattice. A lot of times people draw the analogy of thinking about the produce stand at the supermarket, where you see all the oranges stacked together, the little spheres. It'd be like if you had oranges of two different sizes, perhaps, or two different colors stacked together, and there's little gaps or holes between it. But the point here is that to make an ionic compound come together with a very specific ratio of atoms, we have to be very precise about how the ions pack together to form the 3D lattice. And this is a drawing of how barium fluoride works. I hope to give you an idea of how all ionic compounds work as a result of this drawing. So first, note the greenish, larger colored spheres that are sort of towards the center of the cube, okay? Those are our fluoride ions. That's our F- ion. Fluoride likes to form a -1 anion by gaining an electron so that it can be isoelectronic with the next nearest noble gas, which is right to its right in the periodic table, and that's neon. If it picks up an electron, it's just like neon. Remember, that's stable, so that's what it does. So those greenish colored spheres are fluoride. Now, if you project to the volume of this 3D box, can we count how many fluoride ions are inside this box? I think we can. Looks like there's 4 on the top, 4 on the bottom. That makes a total of 8 as far as I can count, okay? So 4 on the top, 4 on the bottom. Now with those fluorides, those spheres are completely contained within this one unit cell, as chemists call it. They belong completely to this one unit cell. So there's 8 fluorides within the unit cell. We'll get back to that here later, okay? But before we do, now let's consider the gray colored spheres, okay, that are kind of around the periphery. Now these are the bariums. Now these are even more complicated, okay? Notice that there's a lot of them present, and they're all a little bit different, okay? I'm going to separate them into 2 different categories. The first category are going to be the bariums, which are present at the corners of the spheres. The corners of the spheres. So there's 1, 2, 3, 4 on the top. 1, 2, 3, 4 also on the bottom. These are the ones just on the corners. Now those are interesting because they're partially present within this unit sphere, but as it turns out, this unit sphere doesn't exist by itself, or this unit cell doesn't exist by itself. Each of these bariums on the corner would also be surrounded by 7 other unit cells. So these corner pieces only belong 1/8 to this particular unit cell. And there'd be 7 others surrounding them on the top and on the side. Now, the other bariums that are of interest are on the faces of the cubes. These are the ones that are more highlighted in red. Here, 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 and then there's one on the back, okay? These, so we might call it face-centered barium atoms, belong partially to this unit cell, and they also belong to their nearest neighbor. So they're actually a 50% contribution to this unit cell and 50% to the nearest neighbor. So as a result, there are 1, 2, 3, 4, 5, 6 of these face-centered bariums. 50% contribution to this unit cell, so that's actually 3 barium atoms for the face-centered. And then remember, each on the corner have 8th contribution. There were 8 of them, so that's an additional 1. So it turns out that this unit cell has 4 barium atoms that's associated with it. along with the 8 fluorides that we talked about earlier in green. So you can see then, if you do this inventory of the particles, there's 4 bariums, 8 fluorides. That's consistent with BaF2, or a 1:2 ratio between these elements. And that's how we basically build this ionic compound. Now, because this is organized in a complex 3D lattice, we don't call these molecules. Instead, chemists tend to call the base unit for ionic compounds formula units. Formula units. So if you hear that thrown around, that's basically what we're talking about. This is basic stoichiometric ratio between the elements for an ionic compound. Okay, so that's how this is organized. I hope this video was helpful.